Hello and welcome guys in the machine learning tutorial. So now in this video we will be learning about logistic regression. So this is a classification algorithm and it is supervised. So let's understand what exactly logistic regression is. And one more thing that I wanted to share, that is, don't go with the name, as it says regression, but it's not a regression, it's a classification algorithm. Okay, so let's understand the working and mathematical intuition. So logistic regression is like trying to predict whether something will happen or not based on some clues you have. For example, if you have a dark cloud in the sky, you might predict that it's going to rain. In logistic regression, we use clues called predictor variable to try to predict the likelihood of something happening or not happening. Let's say we want to predict whether a person will like a certain type of candy or not. So we can use some predictor variable such as their age, gender, and whether they like other similar type of candy. So we can use these clues to try to predict the likelihood of them liking the new type of candy. To do this, we use something called sigmoid curve. The curve that you see here, it's in S shape, right? That's why it's called a sigmoid curve. So this curve gives us a number between 0 and 1. Okay, so you can see the range here, it's from 0 to 1, and this middle line is the threshold value. Okay, so so it represents the probability of person liking the candy. Okay, so whatever the probability will be, so if the probability is, say, here y equal to 0.3, then obviously it will belong to whatever the class 0 is. If the value of y equal to 0.8, then it will belong to class 1. Okay, so basically this curve gives us number between 0 and 1, which represent probability of people liking the candy. If the number is closer to 0, means it's unlikely they will like it. If the number is close to 1, it means it's very likely they will like it. So we can use this sigmoid curve to create a mathematical equation that uses the predictor variable to predict the probability of someone liking the candy. So the that equation is called logistic regression model. Okay, so once we have this model, we can use it to make prediction about whether someone will like the candy or not based on their features, for example age, gender, and whether they like other similar type of candy. It's like using clues to solve a mystery. So in summary, logistic regression is a way to predict whether something will happen or not based on clues. That is called predictor variable. We can use a sigmoid curve to give us a number between 0 and 1, which represent the probability of event happening or not happening. We create a mathematical equation using this predictor variable to predict the probability of the event and use it to make prediction about event happening or not happening. Okay, so that is what it is. So now let's understand a little bit about curves. Okay, yeah, okay, so for a binary classification data set, if a line or a plane can almost or perfectly separate two class, then that data set is called linearly separable data set that you see here. I mean, you can see that the classification has been perfectly separating two classes. This is 1, this is 0. So in that case, that will be called as perfectly separable and linearly separable data set. Okay, so if the two class cannot be separated by a line or a plane, then the data set is not separable. Okay, so if for example, let's say you have data here also, I mean, let's change the color. Okay, let's say you have data also like this thing. Okay, here also. Let me remove this. Okay, now select blue color. Okay, so now let's say you have blue points here also. So you can see, right, I mean, if you draw a line from in any direction, let's say this direction, okay, you will still have both the classes in this zone, both the classes in this zone. So you can see, right, I mean, sometime your data set will contain data set like that, like it won't be, you won't be able to separate two classes by a line or a plane. Then this type of data set is called non-linearly separable data set. Okay, so in order to deal with this problem, I mean, you understood, right, the problem. So basically you have a data set and you can see that you have blue points here, red points here, blue points here, and if you want to create a line where you can separate these both classes, it's not possible currently, right? It was possible earlier when we have data like this, but it wasn't possible if you have blue points here or red point here, right? It won't be possible. So in order to deal with this problem, we need to modify the optimization equation by applying a technique called squashing. Okay, so the idea behind squashing is that if the distance of a point from the plane is small, then we can use it as it uh, uh, as it is. But if the distance is large, then we have to convert it to small value. Okay, so now let's understand the concept of convexity. Okay, so convexity is a property of function where the line segment between any 2 points on the function lies above or on the function, that you can see here, like it's lying above, right? So mathematically, a function is a convex if its second derivative is non-negative everywhere. Okay, and you can see that, in this case, it's not lying on the non-negative region. Okay, so in logistic regression, the likelihood function that is maximized to estimate the coefficient is a concave function, which means that uh, that is type of function that is always below on a tangent line. Okay, so this property of the likelihood function make the optimization problem convex. So as a result, optimization algorithm can guarantee to find the global optimum, which is set of coefficient that maximize the likelihood function. So on the other hand, that we see non-convex. So non-convexity referred to a function that is obviously not convex. Non-convex optimization problem are more difficult to solve because they have multiple local optimas, which are set of coefficient that optimize the function within a small region of parameter space. So if the optimization algorithm gets stuck in one of the local optima, it may fail to find the global optimum, which can lead to suboptimal or unreliable model result. So in summary, this logistic regression is a convex optimization problem because the likelihood function is concave, which allow optimization algorithm to find the global minimum of the function. So non-convex optimization problem are more challenging to solve because they may have multiple local optima, and that can lead to suboptimal result. Now let's understand this thing mathematically. Okay, so like we just understand, logistic regression is a statistical technique which is used to model the probability of binary problems like yes or no problem, or categorical or multiple class problems. So outcome will be based on one or two or more predictor variable, and it is a type of generalized linear model that uses a logistic function, also known as sigmoid function or sigmoid curve, to model the relationship between predictor variable and the outcome variable. So the logistic regression is a S-shaped curve that range between 0 and 1, and it is used to map any real value to a probability between 0 and 1. So the logistic regression, this logistic regression function is defined as fx equal to 1 by 1 plus e to the power minus x. Now x is the input, e is the base of the natural logarithm. So the logistic function can be expressed as the ratio of two odds, namely the odds of the event occurring and the odd of the event not occurring, which is fx equal to p by 1 minus p, where p is the probability of event occurring. Okay, so the logistic regression model assumes that the log odds of the outcome variable is linear function of the predictor variable. So mathematically, the logistic regression model can be expressed as logit of p equal to log p by 1 minus p, which is this one, the upper function, equal to beta naught plus beta 1 x1, beta 2 x2 plus dot 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 beta n xn, where logit of p is the log odd of outcome variable, or you can say y also, and beta 0, beta naught, beta 2, these are coefficient of logistic regression equation, and the logistic function is then applied to log odd to convert them into probability, which is 1 by 1 plus e to the power minus x, or you can say logit of p. Okay, so that is what it basically tells. Now next thing is, so then the decision boundary is a line where the probability of outcome variable being 1 is 0.5. So let me show you. So in this graph, that is the line that you see here, dotted line, is a boundary line. Okay, decision boundary line. So the line correspond to value of z where where y equal to it will be 0.5. So this is a point where the sigmoid curve actually intersect the horizontal line at value of 0.5, and this particular point is found by solving the equation of z. Okay, which will given as z equal to beta 0 plus beta 1 x1 plus beta 2 x2 equal to 0. So the logistic regression model is estimated using maximum likelihood estimation, which seeks to find the value of coefficient that maximize the likelihood of observed data. So the sigmoid curve, also known as logistic function, is a mathematical function that map any real value input to a probability between 0 and 1. So the sigmoid curve has S-shaped curve which start from the 0. Okay, so you see the green dotted line. Okay, and it rise to maximum value of 1 and then it fall back to 0. So the sigmoid curve is commonly used in logistic regression to model the relationship between predictor variable and the outcome variable with this equation. Okay, this particular equation. Now what is log likelihood? Likelihood, or I was saying maximum likelihood estimation, what is it? So basically the log likelihood is a measure of how well a logistic regression model fit the data. So in logistic regression we are trying to predict the probability of a binary outcome, whether a customer will buy a product or not, so based on one or more predictive variable, like for example age, income, location. So the logistic regression model uses a logic function, that is sigmoid curve, to convert the linear combination of predictive variable into a probability value. So the log likelihood is a mathematical function that measure how well the predicted probability from the logistic regression model match the actual outcome in the data. So it is calculated by taking the logarithm of likelihood function, which is the probability of outcome, observed outcome given the logistic regression model. So this log likelihood is used to estimate coefficient of logistic regression model. So the goal is to find the set of coefficient that maximizes the log likelihood, and this is usually done using optimization algorithm like maximum likelihood estimation, okay, or you can say gradient descent. So in summary, this log likelihood is a mathematical function that measure how well a logistic regression model fit the data, and it is used to estimate the coefficient of model by finding set of coefficient that maximize the log likelihood. So the coefficient of logistic regression model are estimated obviously using this maximum likelihood estimation algorithm that finds the value of coefficient that maximize the likelihood of observed outcome given a logistic regression model. So the likelihood is calculated as a product of predicted probability of the outcome variable for each observation in the data set. The log likelihood is then calculated as the logarithm of likelihood, which make it easier to work with mathematically. Okay, so the coefficient that maximize the log likelihood are the one that provide the best fit to the data in terms of predicting the observed outcome. So the interpretation of coefficient will be like, so once the coefficient are estimated, they can interpret interpreted to determine the effect of each predictor variable on the probability of outcome variable. For example, if the coefficient of age is positive, it means that increasing age increase the probability of outcome variable, or you can say buying a product. So holding all other product other predictor also variable constant. So this involve iteratively updating the value of coefficient until convergence is reached, and the maximum of likelihood function is found. So ultimately the goal of logistic regression is to find a line or hyperplane in the higher dimension that separates two classes in data space. This is called decision boundary. Now to understand step by step, so basically first we define the problem, determine what you want to predict and what predictor variable you want to use to make the prediction. For example, you might want to predict whether a customer will buy a product on their age, income, education and location features. Then collection of data. So basically here we gather data on the predictor variable and the outcome variable, whether or not the customer bought the product. Then transformation of data comes. So here we convert the predictor variable and the outcome variable into a format suitable for logistic regression. For example, you might convert the outcome variable to 1 if the customer bought the product and 0 if they did not. So you might also standardize the predictor variable so that they have a mean of 0 and a standard deviation of 1. Then we split the data. I mean the process architecture will be same as it is as linear regression or any other algorithm. So in splitting the data, we divide the data into two sets, training and testing set. So the training set will be used to build the logistic regression model, and the test set will be used to evaluate the model accuracy. Then we fit the model. We use training set to fit a logistic regression model. This involves finding the values of the coefficient, that is beta naught, beta 1, 2, etc. That minimize the sum of log likelihood in the data, and the log likelihood measure how well the model predict the observed outcome. Then we evaluate the model. So we use test set to evaluate the accuracy of logistic regression model. This involves calculating the predicted probability of the outcome variable for each observation in the test set and comparing them to get the actual outcome. Then we interpret the coefficient, so interpreting the value of coefficient to determine the effect of each predictor variable on the outcome variable. For example, if the coefficient of age is positive, it means that increasing age increases the probability of outcome variable. Then finally, making the prediction. So we use the logistic regression model to make prediction for new observation, and this involves plugging the values of predictor variable into model equation to calculate the predicted probability of the outcome variables. Now let's see this whole process with one example mathematically. Okay, so this one. Okay, so let's consider a data set with 3 observation and 2 predictor variable, okay, age and income. So the outcome variable y is whether or not person purchase the product. So 1 will be purchased, 0 will be not purchased. Okay, to fit a logistic regression model to this data, we need to specify the model equation, which is p equal to 1 by 1 plus e to the power minus z. Now p is the predicted probability of the outcome variable which is purchased, and the z is the linear combination of predictor variable, that is age and income, which and then weighted by their coefficient beta naught and beta 1. So now to estimate the coefficient beta naught, beta 1, beta 2, we use maximum likelihood estimation. Okay, so maximum which involves the finding of value of coefficient that maximize the log likelihood of observed outcome. So assume that that the initial value of coefficient beta naught 0, beta 1 0, and beta 2 is also 0. Okay, so now what we will do is which will now look like this for all the rows we have. So for z, what we will be doing, we'll putting all the value according to the data set that we have into the formula of this one that you will be seeing here. Then we have p here, so we'll find all the, say accordingly, like we have to do for all the rows. You have to find p, and then you have to find z. All of this be done using these two formula here. Okay, and for now theta will be theta and theta 2 that you see here, theta 1, theta 2, is basically positive values that depend on the estimated coefficient. Okay, so now let's move to another slide. So basically now the log likelihood is then calculated as the sum of logarithm of the predicted variable probability for each of the observation, like this. Okay, log of 0.5 plus log of 0.5 plus theta 1, this one, plus log of 0.5 of theta 2. Okay, like this. And the goal of MLE is to find the value of coefficient that maximize the log likelihood, and this is usually done using the algorithm like gradient descent. So once the coefficient is estimated, and they can be used to predict the probability of outcome variable for new observation based on their age and income. For example, if our estimated coefficient are like b not equal to -1, b1 equal to 0.1, and beta 2 equal to 0.0001. Okay, so the logistic regression model equation would be z equal to -1 plus 0.1 into age column plus 0.00001 into income. Okay, and the predicted probability of purchasing for a person with the age 35 and the income 60,000 would be p equal to 1 by 1 plus e to the power minus z equal to, and you have to just put the values that we have got here. Okay, you have to put the value of z directly here. Okay, and the outcome we will get is 0.6. So the model predict a 60% of chance of the person purchasing the product based on their age and income. Okay, and you see, right, how easy it is to calculate all this value. You just have to use these two formula to calculate the coefficient, and then putting back all the value, and then you will get the predicted probability of person purchasing a cell phone or anything. Okay, so this was it. I hope this mathematical explanation helped. Now let's understand the advantages and disadvantages of logistic regression. So basically, advantages first. So it is simple and easy to interpret. Okay, what I mean by that, so logistic regression is simple and easy to understand method that produces a model that make it interpretable coefficient. So it is often used as a baseline method for comparison with more complex models. Then it is robust to outlier, which means that logistic regression is less sensitive to outlier than other methods such as linear regression. Now it is flexible. So logistic regression can be used for a wide range of data types, including continuous, categorical, and binary variables. it is also efficient. So logistic regression is computationally efficient and can handle large data set. Now what disadvantage it has? So limited to binary outcome only. So logistic regression is limited to modeling binary outcomes, which means that it can only take two values, or you can say two class. So it cannot be used to model outcome with more than two categories. So let's one more topic I will be discussing, how we will be handling multiple classes. So let's say you have dog, cat and parrot to classify. Okay, now since I told you that logistic regression cannot handle more than two classes, there is a way to do so. So let me discuss that in next video. So that is a limitation logistic regression has. Now it assumes linearity. Okay, so that is also one of the most disadvantaged feature. So logistic regression assume a linear relationship between the predictor variable and the log out of outcome variables. So if the relationship is not linear, the model may not fit the data well, like I shown you. Okay, if the data is not linearable, this logistic regression would not be able to fit well. Then logistic regression assume that the observation are independent of each other. So if the observation are correlated, the model may not fit the data well. Again, same thing. This assumption is also a problem in linear regression. Okay, that we have also seen in the code. Now other disadvantage is logistic regression requires a large sample size to obtain an accurate estimate of the coefficient. So if the sample size is small, the model may not fit the data well or produce result that basically matter to us. So hope this is clear, and let me just clear out some of more doubts that is related to the decision boundary. So basically in logistic regression model, the decision boundary is a mathematical function. Okay, this decision boundary is a mathematical function that separates the data point into two classes based on their probability of belonging one class or the other. So in simplest form, the decision boundary is a straight line that divide the data space into two regions. Okay, these two regions corresponding to two classes. However, in some case, the relationship between predictor variable and the outcome variable may not be linear, which means that straight line will not be able to accurately separate two classes. In such cases, a non-linear decision boundary can be used, which will look like S. Okay, you can see here. So the non-linear decision boundary can be represented by more complex mathematical function such as quadratic function or a cubic function or any other non-linear function, and this function allow for more complex relationship between predictor variable and the outcome variable, and can result in decision boundary that is more flexible and able to capture non-linear pattern in the data. So to implement non-linear decision boundary in logistic regression, one approach is to transform the predictor variable using non-linear functions such as polynomial or exponential or logarithm. Okay, and this can done via creating new variable that is non-linear function of the original variable. And including these variable in a logistic regression model. Another approach is to use more complex machine learning algorithm such as support vector machine decision trees, neural networks, which we will be learning later on, which can learn non-linear decision boundaries directly from the data without need of explicit transformation that is needed for logistic regression. So overall, the use of non-linear decision boundary in logistic regression can improve the accuracy of the model and allow to capture the more complex relationship between predictor variable and the outcome variable. However, it may also increase the risk of overfitting if the model is too complex and not generalized well on new data. Okay, and let me tell you about one approach that can solve this non-linear decision boundary problem. So to achieve this non-linear decision boundary, we can use a technique called kernel logistic regression. So this involves transforming the predictor variable into high dimensional space using a kernel function, which can then be used to fit a linear decision boundary in the transform space, and this result in a non-linear decision boundary in the original feature space. And that is how you can solve the problem of non-linear decision boundary. So hope this helps. I mean, see you on next tutorial. We will be looking at multi-class problem, and then we'll go for the implementation.